So in data cleaning, not all bad data is the same. Before you fix a data set, you have to know why it's broken. Is it a random mistake or it is a systematic distortion? Today we are breaking down the difference between error and artifacts, and then we will demonstrate the two ways to fill in missing data using imputation, right? So first let's distinguish the two. On the left we have errors and there are random noise. Think of a typo. Someone enters age 200 instead of 20, right? Or a senior momentarily loses power, or a sensor momentarily loses power. They are unpredictable and usually isolated. On the right hand, we have artifacts. These are systematic, right? They come from the process itself. For example, if you compress an image too much, you get blocky squares. The blockiness isn't a random error. It's systematic result of a compression algorithm. Or if a thermometer maxes out at 100 degrees, seeing 100 repeatedly isn't an error. It's an artifact or a sensor's limit. Well, so that was about the difference. Once we find the missing data, whether caused by error or artifact, we need to fill the gaps. This is called imputation. We will look into two techniques to do. The first is mean imputation and the forward fill. So in the mean imputation, simply taking the average of a column and filling the blanks is fine. It's safe, but it can make your data look flatter than it is, right? The next is the forward fill, taking the last known value and carrying it forward. This is a great for time series data like stock prices, where tomorrow's price is likely similar to today's, right? There you go. Next is the interactive lab. Let's see in this action, right? So if I click on the raw data, this is the data. It's, as you can see, it's broken, right? We can see the gaps at day 4, 5 and 8. The line is broken, right? But when I click on mean imputation, you can see, right? The algorithm calculated the average and plugged it in. Notice how those orange dots sits perfectly in the middle. It works, but it ignores the upward trends of the data. It assumes the missing data, we are just average, right? Now if I apply the forward fill, so if we look at the day 4 and 5, instead of using the average, it just repeated the value from day 3. This creates a step pattern. This prevents the local trend between the averages, right? So in conclusion, we can say that if your data is random, mean imputation is often fine. If your data relies on the time or sequence, forward fill is usually better. Understanding the source of your error is the key to choosing the right fix, right? So this was all about this video. Thank you.